Today I'm going to walk us through how we can deploy rollups with using the Astria shared sequencer network on our local dev cluster here. You can find information about how to do this all on our repo. This is all public information, and you can run this using main right now. We have some commands here using just, which provides some nice easy scripting for us. As we get started here, I have already run these first two commands. These just take a little bit of time and enabled me to pull all of the images locally so we can run through everything just a little bit faster in this demo video. So when we go over here, the first thing I'm going to do, I'm going to go ahead and use a utility that I use called K9s to monitor what's going on in our local Kubernetes setup. And then here, just to show you that we are fully up to date, let's run a git pull. This is exactly what's on main right now. We are going to first start by doing our just deploy Astria local. This is going to create a local Celestia network as well as a local setup of our sequencer. As this gets started up here, Kubernetes will boot and reboot things as things come up online. We start with a Comet BFT node. We can see these are ticking up in terms of height here, going at a pretty rapid pace. This should be about every second. Looks like it's going faster right now. And then we also have the sequencer. This is using the ABCI connection to Comet BFT. This is the app side of that connection. It's written in Rust using the ABCI interface. We're not seeing anything here because there's no transactions that are currently being executed. And then we also have our Celestia local network here. In here, we can see in the app here, we can see that there's blocks being produced. These are going a lot slower than our sequencer network. So you can see I4 just popped in here. And then if we go back over to sequencer, we're also going to see the relayer. The relayer here is running alongside Comet BFT, reading new blocks. These are being gossiped over a network that our rollup will be able to connect to, as well as submitting blocks to data availability on that block timing. So you can see it's handling a lot more. There's a lot more blocks are being created, and those are being gossiped. And then there is also this DA that's happening on bunch aggregation. All right, now that we have this up, let's go ahead and deploy a rollup. This will come with a couple of defaults when we run it the first time, and then we'll deploy a second rollup a little bit later. A few things are created here again. We have three different pods in here. The first is going to be our Geth pod. This is running a lightly modified version of Geth so that we can connect it to our conductor, which is going to drive deterministic execution of transactions. We have the conductor here, which is reading data from that gossip net, as well as accessing data from the Celestia network underneath in order to finalize our blocks. And then lastly, we have the composer. This is going to be following our pending transaction pool in order to submit transactions directly into our sequencer. It wraps those bytes, signs it, and sends it on to our sequencer just by following the pending mempool. We have this all up and running now. In addition, we also get a faucet and we get a block explorer with block scout just by running that single command. So let's go ahead and connect to this real quick here. Let's go ahead and call this the Astria local network. All of these follow the same path. It's going to be executor dot whatever rollup name is, in this case Astria dot local dev dot me. This just redirects to our local host, and it's what it's expecting to listen on. We use the 912559 as the network ID by default, and then let's go ahead and call this RIA. We can save this new network that we've created, and then let's go ahead and switch to that network. We can see we have one account with nothing and then one that's fully funded. This account is one that everyone can use when they fully do this. The private key is actually available in the repo so that you can do testing and such locally. We can see this all exists here. We can also go, as I said, we have a faucet that exists. We can enter in an address here. So if we go to our MetaMask and go to our account with no money, let's transfer some from there to there. Go ahead and click request. This will come through here. It comes through actually pretty rapidly, but MetaMask doesn't always update immediately. We can go to Block Scout and we can see this transaction that went through 15 seconds ago. So that's pretty exciting. And then, yeah, so we have this going. We also have a repo, Astria Web3, with some stuff to generate transactions for us. So let's just do a just generate transactions call here. And this is going to run a for script that is going to run executing a whole bunch of just kind of transactions between accounts and such here. Um, this is slowed actually by Forge itself, which has a delay built in there, so it's not running as quickly as it can. But if we go back to our block explorer, we'll see that we're getting blocks coming in here. They're coming in through one transaction at a time because these transactions aren't executing faster, and we have very fast block times and that underlying sequencer. The next thing we can do here is we have this one rollup. That's exciting to launch a rollup pretty easily. But what if we wanted to launch another? It's a shared sequencer after all. So let's deploy another rollup. We will call this. Let's call it just rollup 2 because I'm unimaginative, and we'll give it a network ID. We're going to spin up, and we'll see that we've created another host of pieces here. As the nodes spin up, Geth is coming up, the faucet will come up here pretty shortly. We can go and let's access, we could add this other account to our MetaMask. I'm not going to do that right now, but we could. And then we can go here. We can do a cast and kind of access this directly. We called this one rollup 2. We can see what the account balance is in this. We can see that there's 0. Let's see, we can do a cast send at nonce 0. Again, we called this rollup 2. And we can see our transaction went through. That's exciting. And if we see our cast balance, ooh, there's money in the account. We also have another, so we can see these blocks are still coming in here from our transaction script. We have an additional Block Scout instance now available at rollup 2. And what we'll see is that we have this one transaction. These are both going through the sequencer. There's nothing transacting here. And we can actually go through here to our sequencer node, and we can see that we have these transactions now that are coming through as these transactions are being generated. They're only being executed on one of our rollups we've created. Another thing we can do here is we can do some manipulation of our nonces so that we can try and get multiple in a block here. Let's do nonce 5, and because that one's not going to actually execute, 4. These aren't going to execute right away because we don't have a valid nonce yet. We're going to do 2. And then let's execute it at nonce 1. So we've just executed, we've been transferring 1, 2, 3, 4. So we have 5 that we're transferring to that account. We can see this ended up, as it all came through, it ended up being branched into 2 separate blocks here, but they all executed just fine, went through. We have 2 transactions. And then we have 3 in the next. And if we go here and we cast our balance, we just added 5 to our balance. We see that we have total balance there of 6. And so yeah, that's the Astria shared sequencer and kind of the ability to easily deploy new rollups on top of it with existing infrastructure.